Okay, welcome everyone to GIA's Knowledge Sessions, a series of talks and seminars about gemology fueled by our decades of research. At GIA, we consider ourselves fortunate to study and learn from gems, and it's our mission to share our discoveries and learnings about the world. I'm excited to kick things off today. I'm Nathan Renfro, the manager of Colored Stones here at GIA, and I'm joined by Nicole Aline, who's a senior staff gemologist at GIA also.
Hi, everyone. So my name is Nicole Aline. I'm a senior staff gemologist here at GIA. A little bit about me. I graduated from Cornell College in Mount Vernon in 2015. I had a double degree in geology and archaeology. From there, I went to the on-campus program in Carlsbad to get my GG degree in 2016. And then I was fortunate enough to get hired by GIA and start working in the identification department. During that time, I completed my GEMA FGA program. I contribute features in the lab note and microworld columns, and I am currently a senior staff gemologist in the Colored Stone department here at GIA. Okay, so GIA laboratories, we are located worldwide, but our colored stone services are located at 5 of these locations. And that's, so we have Carlsbad, New York City, Bangkok, Hong Kong, and our Tokyo laboratory. Okay, so during this journey, we're going to go through about over 4 processes. So we're going to look at the item intake, we'll look at weights and measurements, we'll get the photo identification part of it, and we'll also look at the item return. Okay, so item taken. So currently, with some COVID requirements still in place, not all locations have their drop-off service available or have that client window open. So before you submit your gem, just contact your local client service representative to see your options before submitting your stone. And if you do submit your stone at a location where your requested services, so like I said, the colored stone service is only at 5 of our laboratories, your item will be transported to the appropriate GIA laboratory and then actually be returned to that point of origin. So here we see the client services lounge at the GIA Carlsbad, and next to it is that client window where you'll have that face-to-face with the GIA representative, and you can talk over the report you want, all the information regarding your stone, and actually the process of submitting your stone. And then, of course, if you don't want to submit your stone in person, you can drop it you can ship it in, and all the different locations do have different shipping methods that are accepted. Okay, so when submitting your colored stone, you must first decide if you want your identification or if you want identification and origin reports. And so for the origin report, there's 7 stones that actually qualify for this stone, and that is your ruby, a sapphire, emerald, your Paraíba type tourmaline, red spinel, and alexandrite. So all those 7 stones qualify for an identification and origin report, and all other varieties and species qualify for their identification report. And now those 7 stones that do qualify for the origin report, they can absolutely get an identification report. You don't have to get the origin. They can be any carat size. We do have a maximum weight of 50 kilograms. They can be loose, they can be mounted, they can be rough. And then additionally, you can do some add-on services to your reports. And so there's the damage assessment report, and that's offered in addition to your identification report. And that's to determine if a gemstone has been damaged since polishing. If you are submitting a loose faceted ruby or sapphire that's above 50 points, you can actually get a laser inscription service added. And that's basically adding a personal message, a symbol, a logo, or your GIA report number on its girdle. Okay, so currently GIA is developing its identification and origin traceability report for our colored stones. And so what this would involve is a client submitting a rough stone with the accompanying documentations from where, when, and from whom it was purchased from. And then the lab would examine that stone and all document its physical properties, photograph it, and then return it to the client. The client would then cut it and then resubmit it to GIA. And then again, we would study it, we would confirm all the physical properties, we would rephotograph it, make sure everything lines up correctly. And if it does, we would then, we would create this report. And so you can kind of see the report on the right hand of your screen. So this is our origin and traceability report. So it's all the details of that cut stone. You got your species, you got your variety, your geographical origin. So this example report is for a stone that was had accompanying documents that indicated that it was purchased from the El Dorado Bar in the Missouri River in Montana, USA. And so it states that on the report, you have a nice photograph of the rough and the final cuts. And again, this is currently being developed, but we just wanted to share it with you. And if you are interested in a service like this, please contact the client services at Carlsbad, and they will gladly direct you to the people who can help you with this report. And then of course, on top of that, we also have reports for our diamonds as well as pearls. And now some things that we do have that we offer instead of the reports for colored stones is something called batch services. So we have two different batch services that we offer. And so one is the colored stone sorting and one is quality assurance. And so with these, the client picks one or two items from the list that you can see on the right hand in that graph. So we have some that fall just for the colored stone sorting, and then one's for quality analysis, and then quality analysis does have a little more that you can choose from. And so what the client does is they send in a batch of stones, so a group of them. They have to be loose and hopefully of the same material. And so you pick the options that you would like the sorting service for, and then the gemologist would go through and analyze them per the topic that you pick. And so for the client stone sorting, the stones that do pass, so they do pass the heat treatment or no heat treatment call, if that's what the client picked, those actually go on and receive an ident or an ident origin report per whichever the client would like. And then what don't pass actually gets returned to the client. And for quality assurance, what's a little bit different is that the ones that do and don't pass, we don't do reports or return them. They're actually presented on a table format, which I'll show you in a second. So again, we have a lot of options you can choose from. So for both services, you can do a pot of parasha, a pigeon blood, or royal blue call for your sapphires. If you have jade, you can do an impregnation call. And then for that QA, you can do presence of dye. If it's rubies, you can do Burma or non-Burma. And so there are some things that you can't submit. So you can't submit things like amber or turquoise. They can't be mounted. They can't have already received an identification or identification origin report. And again, you can pick up up to two. And then let me show you what that QA service looks like. So again, the ones that pass for the CSS, those get ident or ident origin reports, but for the quality assurance service, they get listed in this really nice table format. So you can see all at the end, there's that the service that the client picked, and that was heat or no heat. Okay, so once a stone has been submitted, is now going to head to our weights and measures department. Okay, so here we see a loose stone. So when a loose stone enters weights and measures, it will actually place on this non-optical measurement device that you see in the photo all the way to the left. And so this device will produce a shadow that you see in that middle image. And what this is doing, it's getting an accurate measurement of all the angles and the facets of the stone, so we can get accurate measurements of it. And then what's cool about that shadow, we can see if there's any like fuzzies on it or like a piece of hair that might actually be adding like some measurement to it. So we just want to get the most accurate measurement possible. And again, if a stone is too big or mounted, it will be measured by hand. And then you can see on the far right how it shows up on the computer. So we can see all those angles and the measurements of this stone. So that's the measurement portion of it. So then what about weight? Okay, so here's the stone getting weighted. And so you can see that there's a loose stone in there. Again, if it's too large for that device or mounted, it will be by hand. And what's cool about this is that in weights and measurements, again, if we're able to calculate the facets and the measurements of the stone and get an accurate weight, they're actually able to produce a specific gravity for us of this stone. And they're gonna do like by the mass and the volume of the stone and compare it to the density of that water. So we're able to calculate the density, and then we have the density of water, and that produces our specific gravity. And then again, if it isn't able to be calculated upstairs in weights and measurements, then we can actually just do it by the old school way of hydrostatic weighing, not really old school, the standardized way of measuring it if the gemologist does need that specific gravity. Okay, so we have all the information collected. Our stone is ready to go and be transported throughout the laboratory. But before it's able to do that, it does require a unique barcode. And this unique barcode is an internal barcode, and it is used to track it throughout its entire process at GIA. So it gets that unique barcode, it puts in a cassette, and you can see it has all its information on it, what report it has, all the steps that needed to be completed for that stone. And this barcode is not shared with the client. And the one number that the gemologists do have that is shared by all parties, that is that report number. But the client actually will not receive that report number until the service is completed. And so at the end of the day, the only staff that will have full visibility of all the stones information, so all the numbers, is the GI staff that will interact with you, the clients, directly. So our stomologists have our own information and is not shared with the client and vice versa, but our client services who interacts with you has full visibility of these reports. Okay, so it's got all its tracking information, it got weights and measures, and now it's ready to be. So on the left side over here, we see the item getting prepped for its digital image. And the main objective here is to record the face-up appearance of this gemstone, loose or in the mounting. And so on the right, the photographer is now double checking that the photograph accurately represents the stone. So in terms of color, is it documenting face-up features? So this is a really important step because we really want to make sure our photograph accurately represents your stone or the mounting and jewelry piece that you have sent in. Okay. So it's been photographed. It is now ready for identification. Okay, so here in the identification department, we use many advanced testing machines that assist with our calls. Those calls could be like our treatment calls or even our origin calls. And so prior to being analyzed, the majority of our stones will go through a sorting step just to decipher what advanced testing needs to be picked per stone. And that's because each stone might need one testing, or some stones don't need any advanced testing, or they might need all 5 of them. And I say all 5 because the 5 that we most use in the ident department and that you can see on that label is our Fourier infrared spectrometer, our UV-Vis spectrometer, our energy dispersive X-ray spectroscopy, our laser ablation inductively coupled mass spectrometer, and our Raman spectroscopy. And so we'll go over each of those advanced testing and what they do and how we use them in the lab and what stones might qualify for those. And then once that testing is completed, the data is going to be stored in a GIA digital database. And that data can then be pulled and analyzed by all our staff gemologists. Okay, so let's talk about a little bit of our advanced testing and what might be used for each testing. So the first one we're going to talk about is the Fourier Transform Infrared Spectrometer. And that's a very long name. So in the lab, we just call it an IR. And so the IR is used to measure the absorption in the infrared part of the electromagnetic spectrum. And as we are looking at the spectrum, so the spectrum is actually going to be created mathematically from our system. And we're going to be looking at the structural components of the material. That is what we're going to be looking for in our at our IR. So the bottom, you can see how we set up a stone in that FTIR. And right there, you can see that stone is pretty small. So if it's mounted, we want to make sure that we're able to get an accurate reading so that it can enter the stone and exit the stone to create a readable spectrum. If it's not readable and it's not clean, it won't be useful for us. So we want to make sure if it's mounted, is it going to be actually able to get a readable IR? Is it too opaque? And so those kind of situations we always have to think about when we're actually going to be getting an IR. And sometimes even if a stone qualifies for IR or we want to get an IR, there's just thoughts of things about it that actually won't help it, such as that mounting or the transparency of that stone. Because again, we want to have that readable spectrum to get accurate data. Okay, so when we use FTIR, again, we're going to be looking at that structural component of the stone, and that can help us with calls such as natural or laboratory grown. And we use that for emeralds and chrysoberyls. We can look to see if we can use it to help to see if a stone has been treated. So for jadeite and turquoise, we can look for polymer peaks. We can use it to assist with heat or note heat calls in some of our corundum. I can show you that. So when we run a piece of corundum, this is a full FTIR spectrum, and you can see it's very big. We got a couple bumps down there, but we're going to zoom in actually. And when we run an IR for our corundum, we're actually only going to be looking at this area, that 2,000 to 3,800 centimeter area. And because this area of the spectrum is actually associated with hydrogen bonds within the corundum lattice. And we're going to be looking at these bonds because the presence of them or the absence of them sometimes actually tells us a lot of information regarding if this stone has seen heat treatment or not. And so an example of that is, so again, we zoomed into that area between 2000 and 3800. And what you're seeing right here is a nice sharp 3161 peak. And this peak is very unstable at elevated temperatures. And so if a stone had this 3161 peak and then it was heated, that peak will actually decrease and be absent from that IR post-heat treatment. So the presence of this 3161 guides the gemologist, assists them in a possible note heat call. But if it wasn't there, it just shows that there is no 3161. We can't decipher if it was heated or no heat, if it was heated or not heated based off the absence of it for this case, but the presence of it guides the gemologist towards a no heat call possible for this stone. So this is how we can use an IR spectrum for natural or laboratory grown call for an example of laboratory grown flux emerald versus natural emerald. So that green spectrum at the top with the 3 distinct features, that's an IR for a natural emerald. And that gray spectrum below it, that's our flux emerald. And you can see the flux is very different. It only has a couple features between that 2000, 3000 area, and then it kind of just tapers off. And so if we're possibly with clean emeralds and we just need a little bit more assistance on that natural versus laboratory grown flux call, an IR is a great place to start here. However, if you do have a hydrothermal growth laboratory grown emerald, their IR can sometimes mimic a natural emerald. And in that case, that's when an IR spectrum wouldn't be helpful to distinguish that natural versus laboratory grown call. Okay, so the next advanced testing machine we have is our ultraviolet visible spectrometer, or UV-Vis. So here the machine will measure and record absorption patterns within the UV to visible light range and into the near IR. So when we look at the absorption patterns in the UV-Vis spectrum, what we are analyzing and looking for is absorptions caused by trace element impurities. And so the collected spectra contribute to our origin calls for blue sapphire. To help us guide if it's metamorphic or magmatic origin. We can look for the presence for copper or iron-related bands in tourmaline. We can run a blue spinel for cobalt-related bands. So again, we're looking for what's causing color in our stone, like what's assisting with our blues, our greens. Is it going to be that copper? Is it going to be the iron? And again, it's just going to help us guide us more towards that affirmative answer. So here is a UV-Vis of a metamorphic blue sapphire. And so you can see that it has this broad absorption band at 580. And this is an intervalence charge transfer of an iron 2+ and titanium 4+. So this band right here at 580 is what's causing that blue color in our stone. And so when I overlay it with a magmatic, the magmatic does have that 580, but it also just has this additional more intense broad band at 880. So when you're running this UV-Vis to again guide you on origin calls and just assist with that call, a UV-Vis is a great test to assist you with, because again, that magmatic will not have that 880 band while that metamorphic won't. Okay, so here's 2 UV-Vises of 2 different tourmalines. So that blue top one has 2 bands at 690 and 900. Sorry, 690 and 900. I almost said 710. And those 2 features are related to copper bands. And so this tourmaline, if that spectrum was ran and this is what was produced, that 690 and 900, this tourmaline could potentially be possibly qualify for a Paraíba comment on your report and qualify for that Paraíba origin. However, if it was ran and you got this band, the maroon band at the bottom with that 710, that band is actually iron related. So this tourmaline would not qualify for that Paraíba comment because it's not colored by that copper, it's actually colored by iron. Okay, so the next test we have is our energy dispersive X-ray spectroscopy, or XRF. Again, we like our short little syllables here in the identification department. And so this is a quantitative determination of a gem's chemical composition, and it is used to aid in the detection of color-enhancing coatings and treatments. And examples of when we might use this technique is checking for levels of potassium in turquoise to see if it was Zachary treated or not. We can use it for our rubies if we think that it was a manufactured product consisting of lead glass. We can again use it for tourmaline to check for that copper, the manganese, the presence of chrome. We can use it for possible tanzanite coating. So again, we're going to be looking for cobalt and titanium in this case. So here's 2 here's two of what our EDXRF produces. So again, we're not going to be having like spectrums, but we're going to have these nice little graphs that we're going to be looking at. So on the left, you see a turquoise that just has iron, you got some copper, you got some aluminum. And so this probably was not treated by the Zachary treatment. But the one on your right, you see those high levels of potassium indicated by its symbol K. So this turquoise will be pushed along for Zachary treatment. So again, no potassium, potassium. And the same thing is kind of what's going to look like for a lead glass filled ruby as well. So on the left-hand side of the screen, you see ruby was ran, you only got your copper and you only got your iron was found. And then on the other graph, you see that actually very, very high levels of lead, again, indicated by its symbol PB. So this ruby, again, with additional confirmation, so maybe gas bubbles, filled veins, with this XRF showing proof of lead being present, this ruby will now be probably sent out as a manufactured product consisting of your ruby and your lead glass. Okay, so pictured here is our laser ablation inductively coupled plasma mass spectrometer, or ICP. And this device is highly sensitive and it collects qualitative data, and it's analyzing the chemical composition of the stones in parts per million. It's rather quick and direct examination of both loose and mounted gemstones, and it can do precise measurements of a wide range of elements and down to ultra trace amounts. And this device is helping the lab with treatment calls such as beryllium diffusion. It provides us data for all our geographic origin calls. It can also aid in a natural laboratory grown call as well for a wide range of stones. And so the sample that is taken, when I say very small, think about like the size of a human hair. It's roughly 50 microns. It's a very small sample. And so you can see in the bottom photograph that silver metal, that's a dime. That's the edge of a dime. So those holes are very small. And then you also have the machine to your right. Okay, so the last test that we'll discuss is Raman spectroscopy. And this test supports the identity of a gemstone as well as some inclusions within a stone. And so what happens is a laser or another light source illuminates the surface of that gemstone or the inclusion that you're testing. And as that light interacts with the material, it creates vibrations on the molecular bond. And this results in re-emission of light in different wavelengths. So we collect that light, we analyze it, and we're going to produce a Raman spectrum. And this spectrum is then compared to known samples in our database to determine the identity of the material. And this works really well because almost all stones have a distinct Raman spectrum. And Raman can help us with the identification of a rough or an aggregated material if the surface is too rough to get the polish isn't clean enough to get a clean refractive index. We can also use it when we identify inclusions. Many inclusions, once they are identified, are strong indicators for a specific origin call. And some examples of these include tourmaline inclusions in blue sapphires from Kashmir or apatite crystals in spinel from Burma. Another way we use Raman spectroscopy is for additional proof for a natural or dye call in red coral. And so the red spectrum shows two dominant peaks. And so we're seeing peaks at around 1520 and 1123. And these are carotene peaks. And carotene is the organic pigment that's actually responsible for that pink to red shade in our natural color coral. So that red spectrum, or the black spectrum that's overlaid with it, is those two peaks are absent. And so that was ran against a red color piece of coral. And since those carotene peaks are absent, the gemologist is going to be leaning towards a dye call for this stone, because again, we're looking for those two peaks for a natural color. So here's an example of using Raman for an assistance in an origin call. So this nice bright red crystal was identified as pyrochlore, and this when it's bright red like that, bright red pyrochlore is commonly found in blue sapphires from Cambodia. So it's identified. We have bright red pyrochlore. Our gemologist is probably going to be leaning towards Cambodia for the origin. Now, if it wasn't bright red, maybe it was orange, the gemologist might be leaning another direction for the origin of this stone. So this stone received a Raman spectrum due to the rough surface interfering with getting a clean refractive index. And it has a spectrum for topaz, but it was polished and carved to imitate a diamond. And so a diamond has an SG of 3.52, and topaz has a very similar SG of about 3.5 to 3.6. So the SG wasn't useful in determining the identification of this stone, but this spectrum was. And let me show you this is the Raman of a diamond, so very different. So with using that Raman, the stone presumably being double refractive, and also inclusions present in the stone, was the evidence that this gemologist needed to correctly identify the stone as a topaz. Okay, so the advanced testing that was needed has been done, and all the results are now in our GIA database for our gemologists to grab and analyze, and the stones are now ready to be examined by the staff gemologist. So all stones in the colored stone identification department are looked at by a minimum of 2 gemologists, with at least one being a senior staff gemologist. And the staff gemologist will use all standard testing equipment, and that includes your refractometer, your polariscope, your dichroscope, and your spectroscope, when needed and applicable for each stone. They will also check the stone's SG if needed, the fluorescence, and then the gemologist will also analyze all that data that was collected from that advanced testing, and also decide if the stone maybe needs more testing. And now the most useful tool that I have not talked about yet is to a gemologist is their microscope. And the limitation of the microscope is a user's knowledge. And I can't emphasize enough that the microscope is single-handedly the most important instrument for this. Just provides the gemologist the view into that gemstone's world and all the information you need to collect and develop your answer for the identification of the stone is right there through the scope. So very important tool that us gemologists have. Okay, so I said gemologists might look at the fluorescence of a stone. And fluorescence, what it is, it's the visible light that's being emitted from the stone as it's being hit by ultraviolet radiation. Ultraviolet radiation is a portion of the electromagnetic spectrum between 200 and 400. And so we have 2 light sources here at the GIA laboratories that we use to check fluorescence. So we use the long wave, which is at 365, and the short wave, which is at 254. And so these can be helpful for a couple of different stones. And so in the top right, you see this is a blue sapphire, and it's emitting chocolate fluorescence under shortwave. And this is for when you have a blue sapphire that's a metamorphic origin and it was heated to a certain degree. The rutile in it dissolves at certain temperatures and it reacts with shortwave fluorescence. And what's kind of cool is that you can actually see the fluorescence is following that grain boundary of the rutile, which is kind of cool. Lavender jadeite, if it's dyed, some dye will fluoresce an orange to long wave reaction. So again, not all dye, but some dye do. Pressed amber reacts to long wave and it creates this chocolate fluorescence, and then it kind of follows that the boundaries of all those pieces of amber that I pressed together, and you can see that in the bottom right. Long wave fluorescence can also be super helpful when we're looking at filled fissures and emeralds. So the image on your left is an emerald in dark field. And you can kind of see over here, we have some trapped air bubbles. We have a really nice fingerprint over here. We have a fingerprint over here. We have something going on here. But then when we turn off that dark field and we only use long wave fluorescence, these filled fissures just light up, and it's super helpful for us to find those low relief fissures and just help us get a guide on what our call is going to be if it's an F1, F2, F3. Again, that's minor, moderate, or significant residue in these stones. And kind of just like that lavender jadeite with that orange dye, again, not all filler for emeralds will fluoresce to a long wave. This is just a very perfect example to use to show you all. Okay, so the staff gemologist will also assign a color to the stone. And in the lab, we use the Munsell Book of Color. And the Book of Color is filled with color swatches to give a consistent color call. Now, we do give out certain color calls to align with the trade, such as deep blue for a blue sapphire that would be called royal blue in the trade. We do vivid red for our low iron rubies with strong red fluorescence that would be called pigeon blood. And then we also check all our sapphires to see if they would make the variety called Padparadscha. And those have colors of pinkish orange to orangey pink, and also fall within the definition assigned to them by the LMHC. And then we also, another example is looking at opal to see if that coloration is saturated enough to get a black opal call as well. And so you can kind of see here we have this shows just what the Munsell book looks like. And so we have wide ranges. I believe this is on the yellow side or just the border between orange and yellow. And this is just a 3D modeling, 3D image to show exactly what the Munsell book of color is looking at. Okay, so we got the color. It's finally time for the gemologist to observe our stone. And when you're observing and documenting the stone, again, I just want to reiterate my point one more time that the gemological microscope is the single most important piece of equipment for a gemologist. And when I said that it's limited to the knowledge of the user, I don't mean just knowing the knowledge of how to work the scope, but also what you're looking at. And that includes like the lighting sources that you need to use or not need to use to look at certain features within your stone. And so under the lighting techniques, we have dark field, and dark field is when light is transmitted from below, and then it's actually being blocked by an opaque shield that's commonly black. And so the light is actually coming in from the sides. And this, if inclusions are present within your stone, those inclusions will appear nice and bright on a dark background. And this works best if the stone is transparent to translucent. So the next one is diffused transmitted. And this is when that opaque shield that we use in dark field is removed. And so you have light being transmitted up. And then we actually are placing a white translucent filter over the scope. And so this is ideal for viewing gemstones color zoning because it's softening that light a little bit more. The next light source is reflective light. And this is when that light source is coming from above the stone, and it's actually reflecting off the surface. And it's just a really good way to look at the external characteristics of your stone. So you can see if a stone's been filled, any damage, if maybe glass droplets on the surface of your stone. And then the last lighting technique we'll talk about is a fiber optic light. And this is the most highly effective and most versatile, as it can illuminate a stone from any angle. And having access to that fiber optic light will just increase a gemologist's chance of properly identifying a gemstone, finding the smallest features about it, really just finding all the treatments that are there. And again, this also works with transparent to opaque gems, both loose and mounted. So the fiber optic is just the most versatile out of all the lighting techniques. And so this is kind of an example why. So the image on your left is a Mozambique ruby just being shown with dark field illumination. So you can see that there's a feature breaking the surface. You got some particles behind it. But when you don't turn off that dark field and you just use that fiber optic light, the silk that is just commonly found within Mozambique just lights right up. So dark field versus fiber optic, you're just seeing two very different features from these rubies. And another example here, so on the left, we have a ruby again with dark field illumination with fiber optic, and we can see that there's numerous filled fissures in it. So this stone has seen high heat treatment. And when we only use reflective illumination on that same area, there's actually a filled cavity there. And so that filled cavity, we do count it as a treatment and it will be reported on your report, but that wouldn't be found without the use of that reflective illumination and lighting technique. Okay, so when a staff gemologist is analyzing the stone, examining the external and internal features, and they're also gonna be examining if the stone is mounted, they're gonna be looking at jewelry and mounting as well. So for external features, we're going to be looking at the presence for coating, if there are glass droplets or filled cavities present, if the stone examining is being assembled. So in this image, you can see this is an assembled opal. So we have natural opal on the top and then a manufactured product base. So this is an assembled opal. If the stone is damaged in any way. Internal features, we're going to be looking for documenting areas of the stone if it has been dyed or clarity enhanced. So this is a classic flash effect from a filled emerald fissure. We're going to be looking for evidence for a natural laboratory grown call. So what we see here is a flux fingerprint in a laboratory grown spinel. I'm seeing here, this is a stringer of gas bubbles found in a glass bangle imitating jadeite. They will also look at the inclusions present and the nature of them. So if the stone has potential to be heated, then all of the inclusion, are the inclusions still intact? So here we see unaltered uraninite crystals and they don't show evidence of heat. However, if uraninite is heated, this is what they will look like. And we call these snowball crystals. So you can see it just this has this white frosted appearance around it once heated, but prior to being heated, there are these, you have sharp grain boundaries on these black crystals. Again, so we're gonna be looking at how the inclusions interact with the stone. Are they higher or lower relief than the host stone? When we're looking at the mounting, we're gonna see if it's undamaged and making sure that there's nothing missing from it. is the mountain influencing the stone in any way? That mean, is it trying to hide an assemblage in your gemstone? So we're analyzing every portion of our stone thoroughly and documenting it all. And just a great example of always thoroughly checking your stones, and again, knowing what you're looking at, is this manufactured golden quartz jewelry that can be seen in the winter 2018 G&G. And so the ring and two bracelets were submitted. And when analyzing the pieces, the yellow metallic veins were inorganic looking. And so you can see that in that bottom left photo. There's pieces of polymer running alongside that quartz vein, and they're actually not flush with the host quartz. But when you're looking at the piece on the right, this is a natural golden quartz with that gold just being more irregular and also showing a natural nugget structure below that surface. So another tool that a preliminary gemologist might use is immersion. In GIA, laboratories commonly use methylene iodide, and it is toxic and should always be used with caution if you are handling it. And methylene iodide has a refractive index of 1.741, and that is very close to the refractive index of corundum, which is 1.77, 1.762. And that's because corundum is commonly frequently immersed the most. It's the most, the commonly most immersed stone at the laboratory. So using a liquid that has a refractive index just closer to the immersed stone will help reduce refraction and reflection to easily see that color zoning and growth structure. So it's just going to hide those facets a little bit better for you. And so we can see that in that bottom middle picture is a titanium diffused sapphire in immersion using that diffused transmitted light. And that blue color confined to the facet junctions is easily visible in this aid of immersion. So this video, I'm going to see if it'll work. Oh, great. It's a little bit loud. And so what we're seeing here is a flame fusion laboratory grown sapphire in immersion under cross polarized light and looking down that C axis. And what you're seeing are these Plato lines, so that cross features. And Plato lines is you're observing proof basically that this stone has a laboratory grown origin for this stone, because Plato lines is the growth structure that is the result of excessive strain on that boule. So not seeing those Plato lines doesn't mean that you might not have a laboratory grown sapphire, might just not be flame, but it's not a flame fusion laboratory grown. So seeing those Plato lines is a great proof of laboratory grown flame fusion. Okay, so let's analyze some stones and just see at the start to finish of the testing and what a gemologist might document. So we're gonna look at 3 test stones. We have A, B, and C. So A is up. Okay, so here's test stone A. It came in for an identification origin report. It's a loose green stone. The gemologist is noting it's transparent, it's octagonal in shape, it's a step cut. Its specific gravity is 2.74. It has a refractive index of 1.59 to 1.582. The gemologist is probably now leaning that they have a beryl. It's green in color. Does it qualify for emerald? So they're going to check that handheld spectroscope for chromium bands. If they're present, that's great. And because it's an emerald, they're going to hit it with that long wave fluorescence. And it's got weak orange with fractures, and it's got blue with those growth tubules. And so then they're going to examine this stone. And our gemologists are noting that this stone has large brown red rutile crystals. It's got fluid fingerprints. That's our the evidence that we need that this emerald is a natural emerald. We're always going to, again, check for that fracture filling because it's commonly performed in emeralds to improve their durability and their transparency. So the gemologist notes that there are 2 small low relief fractures. One has evidence of flattened gas bubbles, and you can see in this bottom photo that there is blue flash effect going on. The gemologist also noted that there is a cavity that breaks the surface, as you can see here in this middle photo. So this is where it breaks the surface, and it's actually a filled cavity. So the gemologist will also note on the report that not only is there fracture filling present, but there is a filled cavity. And the gemologist also must decide, is it minor, moderate, or significant for the filling? And they note that the fractures are smaller, and so this will go out as an F1, so minor filling. So out of all the advanced testing that an emerald can be run for, it's actually only going to be sent for ICP. So we're not going to use that infrared to get a spectrum because we have natural features in our stone. And so here we see our ICP data that was collected. So we have 5 elements here that we'll be looking at to assisting with our plots. So we're going to create plots and we're going to overlay them with data from known samples. And so we're going to be looking at emeralds as lithium, potassium, iron, rubidium, and cesium. And so we're going to take this suite of trace elements, and it's going to be referenced to stone again with similar chemistry in the GAA database and plotted against it. And then stones with dissimilar chemistry, they're not going to be shown. And this just helps clear up our plot and again, have more confidence in our calls. So here's our first data set that we're going to be looking at. And the two variables that we have here is cesium and lithium. So again, we have all our origins listed here. We have Ethiopia, Afghanistan, Russia. And so they're all listed here for lithium and cesium. So let's see where our data plots all the way over here. And so we can see that this data set for lithium versus cesium plots really nice with North Carolina. So again, we have numerous plots. We'll show one more. So this time our variables are lithium and rubidium. And again, overlay, we have all our data sets here. And this stone again is plotting with North Carolina. So with our chemistry assisting and just building confidence in our origin call, and with all our inclusions that also align with North Carolina, this stone will be sent out as North Carolina. So we have listed at the top, this is our report. We have an emerald origin report. We have all our details, our results, natural beryl, emerald, geographic origin is North Carolina. We have our treatment, that F1, the minor resin in surface cavities. And then for all our emeralds, we do list out the graph and just details of our calls, just to be a little bit more clear on what that F1 means. Now, for our origin reports, so all 7 that would qualify for it, if they want that origin, it's just like it will just say emerald report at the top. So if it's a tourmaline, it would just say tourmaline report and remove that origin. And then under geographic origin, it would just say not requested. Okay, so test stone B. So again, one loose red stone sent in for an origin report. It's transparent, round, a brilliant cut crown, a step cut pavilion. We got an SG of 3.95. We got a refractive index of 1.772, 1.766, a little high for corundum, and it's red. So we're going to double check to see if we got that ruby spectrum. We got it. Our stone is a ruby. We're going to check that long wave and short fluorescence. It is inert, which means that this ruby would not qualify for that pigeon blood call because we need that low iron, high red fluorescence. So internally, the gemologists are noting that there is altered crystals and melt relics. And these are indications that this stone saw high heat treatment. So it was heated at a very high temperature. We also have internal diffusion that you can see down here in the bottom photo. They're noting that there's partially healed fingerprints and fissures. So not only was this ruby heated, but it was heated at a very high temperature. So this corundum, this ruby did get sent for an IR again to just assist with that more information for that heated call, but this IR ended up just being clean. The only thing that's featured are the 3 little peaks right here, and that's just oil. So this IR was not useful for our determination of heat or no heat of this stone, but we do have those inclusions, which are a slam dunk basically for heat treatment. It isn't for origin. So here we have our ICP chemical analysis of the stone. And we look at 5 elements that are a little bit different from our emerald. So we're going to be looking at magnesium, titanium, vanadium, iron, and gallium. Now, when we do run a stone for ICP and it is a corundum, we also will be looking at our titanium and our beryllium content to assist with the titanium beryllium diffusion call. And so this stone was heated at high temperatures. So let's check out what our beryllium looks like. So those beryllium levels are very high. And with that high temperature heat treatment, the levels are so high that this ruby will go out as beryllium diffused. Now, when a ruby or sapphire is titanium or beryllium diffused, it actually does not qualify anymore for an origin report. And so this report will not be transferred over to an identification report. And so you see that at the top, it doesn't say a ruby origin report. It'll say ruby, just a ruby report. And it goes out a natural corundum ruby, and then we just completely remove a comment about the geographic origin of it. And again, the treatment will be beryllium diffused. So our last test stone is a loose mottled green stone. It's in for an identification report. It's translucent, mottled green in color, and it's a pierced carving. We are unable to get a refractive index due to a poor polish on the surface. We do run it under the polariscope and it's an AGG. And then we do look in the handheld spectroscope and we got chromium bands, which is great because our stone is green. And then we're going to check that fluorescence and it's inert to both long wave and short wave. So our Gemologists are noting when they look at the stone that the stone does have an aggregate structure, so aligning with that polariscope. It does have green body color with no signs of dye, which is great because we got those chrome bands in our handheld spectroscope. There's no indication of repair for this carving. They see no fractures, but they do note in this bottom photo, you can see in pieces and parts of the carving on this stone, there is gray metallic artistic staining present. So not the actual body color of the stone. So we will note that on the report. So since we are unable to get that refractive index, we will want to run a Raman on it. And you can see the black is our reference Raman, and then that test stone C, that maroon one, is actually our stone. And when we run the Raman and we overlay it with known spectrum, our pierced carving ends up to be jadeite. And so we got a piece of jadeite. We know that it's not dyed because we got nice chrome bands, but now we got to check for polymers. We're going to run it through our IR. And this is our spectrum. So this area right here, those dominant peaks right in that 3000 area, those peaks are related to polymer impregnation. If it wasn't polymer impregnated, those peaks would just be absent. And so now we have a piece of jade. It's natural color. It is polymer impregnated. And so we make note of that on our treatment. And we do add a comment for stones that like these, that they are known in the trade as bead jade. Now, if this jadeite, again, no indication of dye, but was not polymer impregnated, it would have the comment sometimes known in the trade as A jade. And then again, we're going to make note of that artistic staining is present for the clients. So once a stone has been seen and analyzed by the preliminary gemologist, a senior gemologist will now examine the stone and the preliminaries observations as well. And they will do everything the preliminary gemologist does, including standard gemology, analyzing all the data that was collected, and just to assure that the stone is being sent out with a consistent call. And now many discussions occur in the colored stones department regarding stones. And so say the preliminary gemologist and the double have differing opinions, a third opinion will be sought after. And just getting opinions and conversing about all the gemstones that come through the department is just what keeps the knowledge flowing through all the GIA laboratories. And the reason that this is so important, it's because we have some individuals here at GIA who have over 120 years combined knowledge and experience of gemology and working in the lab and seeing everything. And so John Cuevla, Shane McClure, and Dino Degano are at the Carlsbad Laboratory, and their knowledge is just unmatched. And so discussing stones and getting their opinions and asking what they're seeing and how they're interpreting things is just one of the ways that younger gemologists here at the lab can just educate themselves and continue to educate themselves on all things colored stones. Now, to have that accurate data set to provide confidence our calls, specifically our origin calls, here at the Colored Stone Department, our research collection, which is collected by our field gemologists and research team from over 95 plus field expeditions, is incredibly reliable. So these samples are collected, which include natural untreated gemstones, natural treated gemstones, included free stones, heavily included stones. They're all studied and analyzed here at the lab to provide us gemologists and researchers with the information that we need or may need in the future just to build our knowledge and expertise and just to assist with our confidence in all our calls here at GIA. And again, so they're going to be, all those stones are analyzed and they're going to be put in that GIA digital database so we can pull and analyze all that data. So our staff gemologists, again, when we are working with that research, we're also active contributors to the Gems and Gemology Journal. And so we're consistently writing entries for the lab note section. And the lab note section is dedicated to interesting things that we see in the lab, things the trade should be aware of, such as new treatments or stones that are just unusual or atypical. There's the microworld section, and that's just looking at the hidden world of gem inclusions through photomicrography, and then Gems News International, and that's global coverage of gem sources or new locations, notable new gem materials, as well as recent industry developments. And then gemology itself is an observational science, and photomicrography is how we document and share the science through the photomicrographs, as well as allowing us gemologists just to the ability to record our observations as well and document them. So photomicrography is a big part of what us gemologists here at the lab also use on a day-to-day basis. I'm sure you've seen some great photos of them. Okay, so the item has been documented. Our report is done, it's time for the item to be returned to the client. So before a stone is sent out, everything on that report will be viewed, checking to see if the word's correct. Does that photo accurately represent the gemstone that you have? Did it print out okay? We don't want any creases or smudges on that report. And then once that report is checked, we're also going to confirm that that gemstone is the one that's on the report and be ready to return to the accurate client. Now you have your stones back. We do offer some follow-up services here at GIA. A client can request a recheck, so they can resubmit their stone to double check the color, the treatment, the identification of, or a geographic origin of their stone. However, should always be aware that they can always just feel free and call and possibly get connected to a senior staff gemologist to discuss the conclusion of their stone. They can request for an update of their stone to confirm their gemstone's information results, even if that gemstone was recut. You could ask for a conversion report. So for your emeralds, that ruby, sapphire, periba-type tourmaline, red spinel, and alexandrite, those can all be converted from an ident to an identification origin or vice versa. And then lastly, we have that report verification. And that's just to confirm your GA report matches that gemstone that you have. And so last, what if you submitted just a really noteworthy or very unique gemstone? We do offer specialty services that are customized with an in-depth information specific to your gemstone once it has that completed report. And so a monograph is a gemologic report designed to display exceptional gemstones. And this monograph tells the complete story of the gemstone with photographs, includes details on the testing performed, some historical backgrounds. And this is all presented in this beautiful handmade box. And if you want to give your gemstone a name, we inscribe the gemstone's name on the box, and you also get a digital copy on a USB drive as well. And a gemstone does have to qualify for this service. A portrait report, though, a gemstone does not have to qualify. And this is a hardbound portfolio that just identifies and discusses the data that supports that conclusion reached on the identification and origin report. And lastly, we have our notable letters. So again, this accompanies a GIA ident or identification report, and it sets out the qualities that make that gemstone noteworthy or unique. So its color, its size, its clarity, its origin, it's all there on that letter. And again, like the letter or like the monograph, it is only available for qualifying stones. And that's the journey of a gemstone at GIA.
All right, thanks, Nikki. So with that, we have time for just a few questions. So can you tell us a little bit about how the mounted stones are actually put into the instruments? So how are we able to do testing? What sort of resources do we use to put mounted gemstones in the instruments here?
Yeah, so if a gemstone is able to fit into the instrument, it can be tested. So as long as it's not completely like bezel set and we're able to get a readable spectrum entering the stone and exiting the stone, it's able to get that spectrum, as well as if it is to get through, is a spectrum that it's collecting readable. Like I showed in weights and measurements, we are measuring all those stones by hand, so those won't see a device when it's getting measured. So yeah, as long as we're able to get the light source in entering it and exiting it, it's able to qualify for an advanced testing. And if again, the advanced testing is done to assist with our call. So if we can't get a test, then the stone just doesn't get tested in that way.
And can you tell us about the photography for the reports? Is that photo intended to be the true size of the gem, or is it a magnified version of the stone? Or what can you tell us about the scale?
So the scale on the report is not true to size. It's just, we just want the photograph to accurately represent the color of that stone and to show any face-up features. So it does not accurately represent the size of the stone.
And let's see, can you have the laser, the report number laser inscribed into colored stones?
Yes, so you can, if you're submitting, so diamonds do qualify for getting a diamond report, but if you're submitting your stone and it is loose, it is above 50 points and it is corundum, so that's ruby and sapphire, those are eligible for inscriptions.
Okay, and if the stone if a mounted stone is mounted in such a way that the mounting prevents certain tests, do we have the mounting or the stone removed from the mounting, or how does that work? And do we do that here, or is that something the client would have to do?
We can absolutely send a stone back to the client and request them to remove it to get better testing if we are unable to identify it. I do know for like some opals, if it's in a mounting, we do make a comment that there is a mounting present, which might hide an assemblage of the stone. And we also have clients that send stuff in with the mounting and it's loose. So we're able to, so they separate it, they send it in, we photograph it in the mounting, and then we test it loose. And we do make a comment on the report that the stone was tested loose.
So they'll still get the photo of the mounting on the report, right?
Mm-hmm.
What do you mean by internal diffusion?
Great question. So internal diffusion, so when you have a rutile is titanium oxide. And so as a stone is heated, that titanium is dissolving out of that rutile and linking up with the iron that's in the host corundum. So internal diffusion, I should start, is a heated comment for corundum, so sapphires and rubies. So as that titanium is leaving the rutile, it's connecting with that iron that's present in corundum, and it's creating that iron titanium intervalence charge and creating like spotty blue color. So internal diffusion is just spotty color created by that dissolution of rutile entering that corundum and creating blue color.
Okay, great. And what's one of the most interesting things you've seen in the lab?
A question that I get asked every day. So what's really cool about us gemologists that we do get to work with G&G and submit features for that the lab notes in the microworld section. Some of the coolest stuff that we do get to write up and share with you in the G&G journal. So some that I have submitted that I think were really, really fascinating were there's a very large rough emerald, and as you turn it, there's a mobile, eye visible mobile inclusion. So on the website, you can actually see that video. And probably most recently is in the GNI, courtesy of Mike Bowers, the Cookie Monster geode.
Right, yeah, that was quite a fun stone. Let's see here. Can you talk a little bit about what are some reasons why we might not be able to determine the origin of a corundum gemstone? What are some of the complicating factors that we might encounter where we would then issue an inconclusive origin?
Yeah, so one of the most definite reasons is we're just not confident in that call, and we don't want to give out a call that we don't have confidence in. So maybe our chemistry just is inconclusive, or it's a clean stone and we don't have inclusions to back up a chemistry call. But I would say that the most common reason that we sent that out is just we don't want to give you an origin that we don't have confidence giving it to you.
Okay. Let's see here. So what are the stones that we do offer origin reports for?
So our corundum, so that's ruby and sapphire, emerald, alexandrite, red spinel, peribatite tourmaline, and I think, am I missing one? I think that's it.
I think that's it for, did you say spinel?
Is that what I was missing? Maybe red spinel?
Maybe. Red spinel, yeah. Okay, and I think that's pretty much got us about out of time for the questions. And so if you have any other questions going forward, you can feel free to reach out to us by Instagram, Facebook, LinkedIn, and Twitter. And so thanks so much for joining us today. And next time we'll be joined by Dr. Chumley Zhu and myself, and we will be discussing the highlights of the summer 2021 issue of Gems in Gemology. So thanks again. Thanks so much for joining.